Good morning, children. Today we are going to discuss matrices. This chapter has a weightage of 3 to 8 marks in your board examinations. Let's define what is a matrix. If mn numbers or functions are arranged in the form of rectangular array, where m is the number of rows and n is the number of columns, then it is matrix of order m into n. For example, if we have 6 elements, then we can form matrices of following order, that is 2 into 3, 3 into 2, 1 into 6, 6 into 1. These are all the possible orders of the matrix containing 6 elements. Now, matrices can be represented with capital alphabet, and in rectangular array form it can be written as Aij with m into n order, where this I is row, this j is column. Similarly, m into n is the order of the matrix. Now, what we can do here is we can expand this matrix As by substituting value of I and j as 1, 2, 3 till n. So if I want to expand this matrix, then I can write it like this. If I say take I as 1 and j as 1, then it can be written as 1 and 1. Next, it is, say I is 1, that means the row is 1 and column is 2, second column. Similarly, this can be written as 1n. Your row is your horizontal line and your column is your vertical line. Similarly, we can write the next row, then we can continue it till nth row. So this can be written as, this is the element of second row and first column. This is an element of second row and second column. Similarly, this will be your element of second row and nth column. We can continue it and expand it. This is an element of nth row and one column. This will be your element of nth row, second column, and so on till A with nth row and nth column. Let's move on to the types of matrices. First of all, it is column matrix. Column matrix has one column, like for example, you can write it as 1, 2, 3. This shows that you have one column. So this is your column matrix. When we talk about row matrix, it will have one row. Row is, again I am telling you, it's horizontally, and column we count vertically. Then we have square matrix. In square matrix, we have row and column equal in number. That means when m equal to n, then we can say it is a square matrix. For example, this is say 2, 1, 3, 4. So here the order of the matrix is, we have 2 rows and we have 2 columns. So the order of the matrix is 2 into 2, which makes it a square matrix. Now come to diagonal matrix. Diagonal matrix is the square matrix in which diagonal elements are present and other elements are 0. So for example, I can say it like this, say diagonal elements, say these are the diagonal elements, rest of the elements are 0. Diagonally the elements exist, rest of the elements are 0. And I told you, as diagonal matrix is a square matrix, that means it should be of order either 2 into 2 or 3 into 3. Here it is of the order 3 into 3. Now come to scalar matrix. Scalar matrix is again a square matrix in which diagonal elements are same. So here I can write it as, say this is my minus 1, 0, 0, 0, minus 1, 0, 0, 0, minus 1. So all the diagonal elements are same. Next is identity matrix. Identity matrix says if your diagonal elements are all 1 and rest of the elements are 0, then it is known as identity matrix. For example, it can be written as 1, 0, 0, 0, 1, 0, 0, 0, 1. This is of order 3 into 3 matrix. Now you come to 0 matrix. If the elements of the matrix are all 0, then we say 0 matrix. For example, 0, 0, 0, 0. This is matrix of order 2 into 2, which has all the elements 0. Now come to equality of matrices. Equality means if two matrices are present in our question, then the element of one matrix is equal to the corresponding element of other matrix. That means if is A equal to 1, 2, 3, 4 and say my B is equal to X, Y minus 3, 2. If these are equal matrices, then we can say that first this element of first row and first column should be equal to the corresponding element. That means this element is of first row and first column. This is again of first row and first column. So the value of X is 1. Here this is first row and second column. Here also this is first row and second column. So these two are equal. So here the value of X is 1 and Y is 2. Minus 3 and minus 3, and it is 4 and 4. So the corresponding elements are same. Now let's see what operations we can do on matrices. We can perform addition, we can perform subtraction, we can also perform multiplication on given two matrices. But addition and subtraction are possible only if the order of the matrix is same. That means if A is of order, say order is 1, 2. So 2 into 1, 2, 3. I can add two matrices if the order remains same. That means B should also be of, say, of order 2 into 3. I can add these two matrices if the order of the two matrices are same. So let's see how we can add. Take the first element of first row and first column, and here also take the element of first row and first column and add them. So 1 plus 0 is 1, 2 plus 1 is 3, 3 plus 1 is 4, 5 plus 3 is 8, 6 plus 1 is 7, 1 plus 0 is 1. So this is how we perform addition of matrix. If we have subtraction, then let's say my B is equal to 0, minus 1, 2, 3, 4 and minus 1. This is again order of 2 into 3. And let's suppose I say perform A minus B operation. So what we can do here is we can write it as A plus minus B. That means write down the matrix A, which is 1, 2, 3, 5, 6, 1, plus I am writing it here minus B. That means you multiply each element of set of matrix B with negative sign. So it becomes 0, plus 1, minus 2, minus 3, minus 4, plus 1. And now you can simply add them. What we can do? 1 plus 0 is 0. 2 plus 1 is 3. 3 minus 2 is 1. 5 minus 3, 2. 6 minus 4 is 2. 1 plus 1 is 2. This is your A minus B matrix. Let's discuss the properties of addition. Matrices are commutative. That means if we add two matrices like this, or if we add matrices like this, then we will get the same result. Associativity. Associativity says if we change the order of the addition, then it doesn't make a difference. That means again you will get a same result. Additive identity. For additive identity, say you have a matrix A, then I can add null matrix so that my matrix will again come out to be same. So your null matrix is your additive identity. And null matrix is what? Null matrix is defined as whose elements, all the elements are 0. Now you come to additive inverse. So if we have a matrix A, then additive inverse of matrix A will be minus A, and it will give me a null matrix. Let's see the multiplication of matrices. Two matrices can be multiplied only if has or follow this rule. If we have matrix A of say m into n order and another matrix is of order n into p, that means your column of first matrix is equal to row of first matrix, then only the multiplication is possible and you will get the result as m into p. That means if you have matrix of order m into n and another matrix of order n into p, the thing is that the column should be equal to row of the second matrix. That means if these two are equal, then the new matrix so formed will be of order m into p. Let's see this with an example. Say if I have 1, 2, 3, 4, that means I have 2 into 2 matrix, and this is your say A, and if I have to multiply or I have to find out AB, then it should be of order 2 into something, because this should be equal to this. Say if I am writing it 2 into say 3 or 2 into 1. 2 means 2 rows. 1, 2, 3. Say it is 0, 0, 1. So 2 rows and 3 columns. So if you have this setup, then only the product is possible. So see how we can multiply these two matrices. If you want to find out A into B, then let's write down matrix A into matrix B. 1, 2, 3, 0, 0, 1. Now you see how you can perform multiplication of two matrices. You have to move always from row to column. From row to column. That means 1 multiply 1, you will be writing it like this. 1 multiply 1 plus 2 multiply 0. Then again this row to this column. So it will be 1 into 2 plus 2 into 0. Then again this row and the third column. So this will be 1 into 3 plus 2 into 1. Then you take next row and then again these 1 columns. So 3 into 1 plus 4 into 0. Again 3 into 2 plus 4 into 0. Again this 3 into 3 plus 4 into 1. This gives me 1 into 1 is 1, 2 into 0 is 0, so this gives me just 1. 2 ones are 2, this is 0, so it is just 2. 1, 3, 3 plus 2, it is just 5. This is 3, 1. 3 into 1 is 3. 3 2s are 6. This is 3 3s are 9 plus 4. So 9 plus 4 is 13. Now you check. I have told you that A into B should be of matrix 2 into 3. Whether you have got it as 2 into 3 or not. So these are my 2 rows. This is my 1 row. This is my second row. So I have the order of this matrix as 2, 1, 2, 3. So 2 into 3 matrix. It is not always necessary that AB is equal to BA. The product of these two will always come out to be different. Let's see now what is transpose of a matrix. Transpose of a matrix means if we convert row into column or column into row, then it gets transposed. We can denote it by, like, if I want to write it transpose, I can write it like this, or I can write it A transpose. For example, if I have matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, and if I want to write its transpose, then you have to convert row into column or column into row. So this is your row 1 into 3, 1, 2, 3. I am converting this row into column and I am writing it as 1, 2, 3. Then my next row is 4, 5, 6. So I am writing it as 4, 5, 6. This is third row 7, 8, 9. So I am writing it 7, 8, 9. So this is transpose of matrix A. Now here it follows some of the properties. If we find transpose of transpose matrix, then we get A. Second property, if K is a scalar quantity, if K is multiplied with matrix A and its transpose is taken, then it can simply be written as scalar quantity A transpose. That means we are just doing transpose of A and it will not affect this scalar quantity. Third property, if we have transpose of sum of two matrices, then it gives me the result same as if we take individual transpose of these matrices. If we have transpose of product of two matrices, then the order changes and it becomes B transpose A transpose. This is important property which you have to keep it in your mind. Now you come to invertible matrices. Previous to this topic, I explained you that AB in multiplication operation, I told you AB cannot be equal to BA. But if in case they become equal and they become equal to I, which is an identity matrix, then the matrix is known as invertible, or inverse of matrix is possible. Inverse of matrix exists. Now let's see what is symmetric and skew symmetric matrices. We can call a matrix as symmetric if its transpose gives me again A. For example, this is an example. If I find transpose of this matrix, that means if I convert row to column, then again I will get the same matrix. It is root 3, 1, 2. This is my second row, which can be written as 1 minus 3 minus 1. This is my next row, which is converted into column. So 2 minus 1 and 7. Now you see here A transpose is equal to A. That means root 3, 1, 2, 1 minus 3 minus 1, 2 minus 1, say. That means if transpose of your matrix comes out to be again that same matrix, then we say it as a symmetric matrix. What is skew symmetric matrix? If you do the transpose of matrix and if you get minus A, then it is known as skew symmetric. The only difference is of minus sign. You will get the same matrix but of negative sign. Now this is a theorem which you have to remember, which says any square matrix can be expressed as the sum of symmetric and skew symmetric matrix. That is, I can write it as matrix A can be written as half of sum of its matrix in transpose plus half of difference of its matrix and its transpose. This you have to remember for the questions to be done.